Now, yesterday, the first report about what it's doing closest to the sun came out. These are instruments that are capable of looking very close to the sun. And it was realized that, in fact, the object is brightening. It becomes very bright right now as it comes close to the sun, and it's turning blue. And the color blue is very surprising because if there is any dust shed off a natural nucleus of a comet, the dust would make it red. And usually the surface of the object is at least an order of magnitude cooler than the surface of the sun. But what the new data indicates is that the object is bluer than the sun. How is that possible?
This morning we have a report that the object got much brighter than expected, and moreover, the color of the object is bluer than the sun. And that's very surprising because usually when there is dust around an object, it should make it red. I should also say that the news yesterday was that this object came closest to the sun, and it received a huge amount of heat from the sun. And the latest report indicates that it became extremely bright, much more than expected for familiar comets.
If you haven't heard yet, something extraordinary just unfolded. 3 days ago, a global network of amateur astronomers released footage that's rewriting everything we thought we knew. The clearest time-lapse ever captured of an interstellar visitor, transforming in real time. 25,000 observers, 61 days of continuous documentation. What they recorded shouldn't be possible. August 29th, 2025. In California, at 3 in the morning, Vamshi Kasieri sits beside his telescope when the alert pings. Object detected. Magnitude 17.8. Over 600 times fainter than the human eye can perceive. His hands tremble as he confirms the coordinates. I just captured an interstellar visitor. Within hours, the network ignites. As California sleeps, Australia takes over, then Europe, then South America. Around-the-clock coverage, no gaps, no silence, every lens locked on the same cosmic enigma. Then something shifts. Mission Control begins quietly revising risk assessments. The object's tail starts to flip direction, turning from the sun to away from it. Its chemistry doesn't match anything known in our solar system. None of it does. And its age? 7 to 14 billion years. Older than Earth itself. Since 3I Atlas burst into view in July 2025, we've learned more about it than any interstellar object in history. But beneath the speculation and media frenzy, one question remains. What's actually verified? What's still unknown? And what might December's close approach reveal? In 65 days, this ancient traveler will reach perihelion, the closest point to the sun. This is our fleeting window to witness a 7-billion-year-old relic awaken. Let's begin with what's confirmed. The time-lapse covers June 7th through September 6th, 2025, 61 days of unbroken observation. Frame-by-frame analysis shows the coma expanding from 13,000 to 26,000 kilometers, doubling in size. The tail, once barely visible, stretches to 56,000 kilometers, 4 Earth diameters. But what makes this sequence historic is what appeared in mid-July. An anti-tail, a dust plume pointing toward the sun physically, that shouldn't happen. Solar radiation pressure pushes dust away, not toward. At first, astronomers suspected a processing glitch. But multiple telescopes, multiple teams, multiple methods, all confirmed the same impossible result. July 15th, anti-tail verified, elongating sunward at 12 arcseconds. August 8th, still visible, starting to curve. September 3rd, complete reversal. The tail now points away from the sun, 30 arcseconds long. That reversal tells us something about the dust itself. Typical comet dust is microscopic, less than 1 micron across, and it's blown away almost instantly by solar radiation. But 3I Atlas is ejecting massive particles, roughly 0.1 millimeters wide, thousands of times larger. These grains are sluggish, barely moved by sunlight. They linger, at first appearing to face the sun, then slowly arcing into the expected direction over weeks. Why such colossal particles? What kind of surface sheds boulder-sized dust instead of fine grains? Is this a property of its ancient composition, or a product of billions of years drifting through interstellar space, fusing tiny fragments together? Dr. Teddy Creda from Lowell Observatory watched the time-lapse 3 times before speaking. I've tracked comets for a decade. I've never seen this transition so clearly. He immediately filed an emergency proposal for December observations. Something is building, and we have 65 days to find out what. Then came the data that shook mission control. August 6, 2025. The James Webb Space Telescope finishes a 4-hour spectroscopic scan at 3.32 astronomical units from the Sun. Dr. Martin Kordener's team runs the spectral readout. Strong CO2 absorption bands. Weak water vapor signatures. He recalculates. Again, the ratio stands carbon dioxide to water 8:1. They verify it 3 times, same result. Here's why that number terrifies scientists. Every comet ever studied in our solar system has a ratio between 0.1 to 1 and 0.5 to 1. Water always dominates. For 3I Atlas, the ratio is 26 times higher than average, 4.5 standard deviations beyond normal. Nearly a once in 500 million case anomaly. And the outgassing rates confirm it. 129 kilograms per second of CO2, but only 6.6 kilograms of water vapor. 19 times more carbon dioxide than water, the exact opposite of every known comet. To put this in perspective, think of a typical comet as a frozen water bottle with some dry ice mixed in. Maybe 20% CO2, 80% water. Now flip that. 3I Atlas is 89% dry ice, 11% water. That composition doesn't exist naturally here. The only places that form CO2-dominant ices are near carbon-rich stars or inside molecular clouds with exotic chemistry. So what happened? Was this its original makeup, born in a carbon-rich cradle? Or was it transformed by something during its journey through the galaxy? This object has been traveling between 7 and 14 billion years, longer than our sun has existed. In 65 days, solar heating will intensify. Activity will spike. If it fragments, we might glimpse material untouched since before Earth formed. Will that reveal familiar ices or even stranger chemistry buried beneath? Then came another puzzle. July 20th, 2025. Spectroscopic scans detect atomic nickel in the coma, 1.8 grams per second. Unusual, but not unprecedented. 2 days later, researchers look for its elemental partner, iron. None. 0. Physically impossible. Nickel and iron are cosmic twins, born together in supernovae, bound in nearly identical proportions across meteorites and asteroids. 19 parts iron to 1 part nickel. Yet here, nickel is rising alone, and it's increasing fast. July 20th, 1.8 grams per second. August 8th, 3.2. August 28th, 4.6. At the same time, cyanide emission climbs in perfect sync from 7.4 to 17.6 grams per second, both accelerating by the same factor. Nickel and cyanide, 2 entirely different compounds, ramping up together. Dr. Binyang from Diego Portales University examined the data. The CN signal makes sense. We see that often, but nickel without iron? That's beyond any formation model. Some theorize selective condensation, nickel minerals forming in hotter zones while iron stayed gaseous. Others propose that over billions of years, iron sublimated away, leaving nickel compounds intact. As of September 2025, there's no consensus. The orbital team then traced its trajectory. Using galactic models, they mapped 3I Atlas back through space. Its path leads to the Milky Way's thick disk, roughly 2,000 light-years from here. Estimated travel time, 7 to 14 billion years. For context, our solar system formed 4.6 billion years ago. Earth's oldest rocks date to 4. The first life appeared 3.8 billion years ago. When this object began its voyage, the sun didn't even exist. It's older than every rock, every crystal, every meteorite humanity has ever touched. It should not have survived. Over billions of years, interstellar dust collisions, stellar flybys, tidal forces, and galactic shear should have torn it apart hundreds of times. Yet it endured, bombarded by high-energy cosmic rays, 1 per square centimeter per second, for 7 billion years. Enough radiation to alter its surface completely, converting water ice into CO2, coating it in organic-rich tholins, dark red and ancient. Its spectral slope confirms this. A reddish-brown, weathered crust, a fossil of the early universe. Dr. Avi analyzed the data. This is the oldest coherent interstellar object ever observed, he said quietly, and it's still alive enough to outgas. How it survived remains a mystery. But perhaps the most remarkable part of this story isn't the chemistry or the physics. It's the people who saw it first. Because professionals have telescopes, but amateurs have time. This discovery wasn't NASA's or ESA's. It was humanity's. Teachers, engineers, retirees, students, 25,000 citizen astronomers across the globe, linked through the Unistellar network. On August 29th, at 3:17 a.m., Vamshi Kisieri used a $4,800 consumer smart telescope to capture an object 600 times fainter than the human eye can see. His telescope's Sony IMX 455 sensor, cooled to perfection, rivaled professional gear from a decade earlier. It was possibly the faintest interstellar object ever recorded by citizen science. From California to Australia to Europe and South America, the relay continued unbroken. Daylight in one region handing off to night in another. Continuous tracking 24 hours a day. Hundreds of images per observer, stitched into a flawless sequence. Each frame processed identically to prevent flicker. 61 days of motion compressed into 6 seconds of haunting beauty. The comet's tail unfurling, flipping, expanding before our eyes. When the final render completed on September 7th, someone posted in the network chat, "We did it. We actually captured an interstellar visitor changing in real time." The chat erupted, messages flooding in from Chile, Japan, Germany, Brazil, Canada. Proof that science belongs to everyone. Professional observatories like Gemini and JWST contributed data no amateur could match. Deep spectroscopy, detailed imagery. But only distributed networks of ordinary people could provide continuous, gapless coverage, documenting a transformation hour by hour. On August 27th, Gemini South in Chile captured the object through multiple filters. A tail stretching 30 arcseconds, 56,000 kilometers long. 6 weeks earlier, it had been only 8,000. A 7-fold increase. Visual proof of accelerating activity. Students watched live from the control room as the image appeared on screen. "Watch carefully," said Dr. Jennifer Lotz. "You're about to see an interstellar traveler after billions of years of silence." Gasps filled the room as the tail emerged, brighter on the sunward side, faintly blue farther out, color gradients revealing particle sorting, large grains near the nucleus, fine dust drifting away. Piece it all together. 61 days of time-lapse data showing structural evolution. Chemistry unlike anything in our solar system. An 8:1 CO2 to water ratio. Spectra showing nickel without iron. Cyanide intensifying. The tail growing 7-fold in weeks. Every sign points to one conclusion. This ancient fragment of another star system is awakening. Solar heat is rising. Sublimation is accelerating. Pressure is building inside its nucleus. In 2020, 2 much younger comets, C/2019 Y4 Atlas and 2I Borisov, both fractured as they neared the Sun. This one has survived for billions of years. But as it approaches perihelion on December 19th, at just $0.80 inside Venus's orbit, it will face its greatest test. Will 3I Atlas endure the Sun's wrath once more, or finally shatter, revealing the frozen core of a time before our world began?